Hello everyone, welcome to UG Academy. In this video, I'm going to talk about customized data types. In previous video, all the variables we declared are of data type that are already defined in the C++ language. But in this video, I'm going to introduce a new C++ concept called Struct, which is actually a collection of different data types, and it can be considered as a user-defined data type. So it's a collection of different data. The syntax of defining a struct is shown here. So you simply type struct, type the name of the struct, and then with these brackets, and then type the data type and the identifier of the data inside. So let's have a look at an example. In this example program, we are going to use struct to construct a type student type. First, let's include the library. In addition to the I/O stream, which is used for input-output program, we are going to also include the string library, which is another data type defined in the C++ library. It is not a fundamental data type, so it is not within the language itself. However, it is in the standard library, so we can use it without defining it by ourselves. Just type include string. String is actually just a character array. But instead of defining a character array ourselves, we just use the string library, which has the best implementation of a character array. Okay. So here is our student struct. It goes like this: student, the struct, and the struct of the name is student. It's a data type called student, and then we also have this name attribute, like the syntax here. Is a data member within the struct, the student struct with this string data type. So actually character array, okay? And then this gender data type I am going to talk about it later. So gender, and then the student ID, which is an integer, naturally. Okay. Then we are going to define this gender data type, which is a enumeration data type. Enumeration data type is another data type that are defined by the user. It goes like this. First, type the keyword enum, E-N-U-M, and then type the name of the enum data type. So in this case, our enum data type is called gender. So we define a new data type by ourselves called gender, and then use a bracket to list the possible value of gender. So of course, there are two possible values for gender, male and female. So here we define a new data type of limited choice by our own. So gender will be a data type that contains only two values, male or female, as defined here. So this is the syntax of enumeration data type defined by user. After having the student struct, we can start see what can we do with the struct data type. So let's start with our main function. First, we can define a student called S1. So this line we define a student called S1. Then we are going to start to assign attribute to the student. In this line, we are only defining the student variable. So all the data types within, so all the data member within the student struct is still undefined. So we are going to assign a value, a valid value for this data member. So for its name, let's call it Peter. We use this dot syntax to access the data member of the struct. So use dot, so access gender. Let's put it at male. Okay. And then also S1, and then dot SID 1, 2, 3, 4, 5, 6. So here we have assigned all the string, also all the data member within the student struct. So it's well initialized now. So let's define another function that print out the contents of this student struct. We cannot directly use cout because this is a data type defined by ourselves, so it's not compatible with cout. Instead, we define a print student info function, which take in a student type argument, and then we are going to use cout to print us its data member name gender and student ID like this. Okay. It says so a struct can be passed into a function as a normal variable like this. Okay. So let's call the function to print out the data member of S1. Also, struct can be copied like this. For example, I define another student type data variable called S2, and then I could assign S1 to it. So what this means is that we copy everything within the S1 here, copy every data member within the S1 and put them to S2. So this is how assigning a struct data type S1 to another struct data type S2 here. So let's check that they are the same. Print it out again. Okay, for sake of time, I've already pre-compiled this program. Let's try it. Okay, exactly what we are going to expect here. Peter 0. Oh, why 0? Oh, the reason for having 0 here is because the underlying representations of this gender data type is actually 0, 1. Okay, male equals to 0, female equals to 1. If there are more other options, they will go to 2, 3, 4, etc. So the computer don't know what is male and female. So in the program, in the underlying program, we actually use an integer to represent male here in the gender data type. Therefore, when we see out it directly becomes 0. So this record indicates that S2 is just a copy of S1, just exactly what we expect. So to fix this problem is also pretty simple. Let's add an if-else statement here. Like if s.gender equals male, or no, if equals 0, then we are going to instead of s.gender, we just replace male here. Else we are going to print out female. Okay. Okay. Let's try to compile it now. G++. So use tab to auto finish. Okay. Exactly what we expected. It becomes male now. That's all for today. Thank you for watching.